My name's Nina, and this bear here is my best friend Bernie. We're here to tell everyone about the great time we had when we visited the 4 inner planets of our solar system. It all started last night when Bernie and I went out in the backyard to look at the stars. That day at school, we had read about the solar system and the inner planets. I told Bernie that I wished we could visit the planets in our solar system. Bernie became very excited at the idea of visiting the other planets and suggested that we try to get ourselves kidnapped by some alien creatures. He thought that maybe we could hitch a ride in their flying saucer to Mercury or Mars. I told Bernie I didn't think that that was such a good idea because maybe the aliens would abduct us and perform horrible experiments, like maybe they would monitor our brainwaves as they forced us to eat boiled cabbage and drink prune juice. Or maybe they would just skip the boiled cabbage and want to eat our brains. Besides, my daddy told me never to accept rides from extraterrestrials. Bernie agreed that hitching a ride wasn't such a good idea. He said he wished we had our own spaceship. Wait, I said. That gives me a great idea. In the last issue of Beulah, Queen of the Universe, Beulah modified a Winnebago with a flat tire into a Zork model, plasma drive, twin propulsion battlecruiser, and used it to completely obliterate the evil Zarblugian Empire. I said, you know, Bernie, if Beulah can change a Winnebago into a battlecruiser, I'll bet we could modify Daddy's old Volkswagen microbus into a spaceship that could at least let us cruise around our solar system. Bernie thought that that was a great plan, so we carried some tools and other essential hardware out to the VW and began our modifications. Daddy's van is pretty old. It took some work, but we had it all ready for interplanetary travel in no time. Then I got Daddy's computer from the den and hardwired it into the van ship's navigational systems. I installed some special solar system software into the external drive, and Bernie hit the power switch. Then things really got going.
Hello, Nina. Hello, Bernie. Are you ready to learn about our solar system?
Hi, computer. Yes, Bernie and I want to learn about the inner planets of our solar system. We want to visit Mercury, Venus, and Mars. And we wanted to learn more about our planet, too.
All right, Nina. I'm plotting trajectories for those planets now. You and Bernie should buckle up. I'm initiating the blast-off sequence to orbit the Earth.
Hold on, Bernie. I hear these takeoffs can be kind of rough. I hope we don't disturb any neighbors. Well, except for Mr. Merkel across the street. He's kind of a crank.
Well, Nina, while we're leaving our atmosphere, maybe I can provide some information about our solar system. The word solar comes from the Latin word for sun. Solar system refers to the sun and all the objects like planets, comets, and asteroids which orbit around the sun and are influenced by its gravity. Our solar system is very large. It is over 11 billion kilometers across. But compared to the universe, our solar system is like a tiny grain of sand in a huge desert.
Well, that is small. Where did our solar system come from?
Our solar system was formed long ago, almost 5 billion years ago. It happened in our galaxy, which we call the Milky Way. At the time, there was no Earth, sun, or even a planet. There was only a vast cloud of dust and gas. Over time, the gas and dust were pushed, pulled, twisted, and shaped by gravity and by electrical and magnetic forces. The cloud of matter gradually flattened into a great disk, the shape of a huge frisbee. Most of the dust and gas were pulled inward to a central core. Away from this core, currents formed in the cloud. Particles began to come together into solid bodies. These bodies began to orbit the central core and continue to attract particles and dust. The core became hotter and hotter until a nuclear reaction occurred. The core ignited and began to shine. A new star was born. The young star produced intense radiation, repelling the gas and dust in the surrounding clouds. The orbiting solid bodies became molten spheres, which slowly began to cool. About 4.5 billion years later, intelligent life appeared on the third sphere from the star. These life forms called themselves Homo sapiens and named the star the Sun. They named the 4 inner spheres Mercury, Venus, Earth, and Mars. These are the inner planets. Beyond the inner planets, 4 giant planets and 1 small planet orbit the Sun. We can do a little comparing to get an idea of the relative sizes of the Sun and the inner planets. Let's pretend this basketball is the Sun. Then, the Earth and Venus would each be the size of a pea. Mars would be the size of a popcorn kernel. Mercury would be the size of the head of a match. Look, Nina, we're far enough up. Now we can see what our planet Earth looks like from space. Heading Earth. Distance from the Sun, 149,600,000 kilometers. Revolution around Sun, 365.2 days. Diameter, 12,756 kilometers. Surface temperature, variable, averages about 15 degrees Celsius.
Wow! Bernie, look at that!
Earth is the largest of the inner planets. It is unique in several ways. Look at the beautiful blue color. There's nothing else like it in the solar system. This color is caused by bodies of water. In fact, 3/4 of the Earth's surface is covered by water. No other planet in our solar system contains bodies of liquid water, not even as large as a puddle. A second unique feature of our planet is life. Earth is the only planet known to support life. As we visit the other planets, we will see how cozy and special our Earth is. We must learn to take better care of her. Another unique aspect of the Earth is the large amount of free oxygen in the atmosphere. Without oxygen to breathe, there would be no people, birds, animals, or insects. Free oxygen also allowed the formation of an ozone shield that protects the plants and animals that live on Earth from harmful ultraviolet radiation. The Earth is a very active planet with many earthquakes and volcanoes.
Let's head for the moon. While we are on the way, I'll review some of the unique facts about Earth. The Earth is the 3rd planet from the Sun. It is the largest of the inner planets. It has free oxygen in its atmosphere. It supports life. 3/4 of the surface is covered by water. It is very active geologically.
Very good, Nina. We are getting close to the moon now. Heading, Earth's moon. Distance from Earth, 384,401 kilometers. Revolution around Earth, 27.32 Earth days. Diameter, 3,476 kilometers. Surface temperature, variable, minus 173 degrees to 110 degrees Celsius. The moon is the only other body in the universe that humans have walked upon. Nina, did you know that your weight is different on each planet or moon because the gravity varies? Since the moon is smaller and less dense than Earth, the moon's gravitational pull on you is less. Nina's weight on Earth, 65 pounds. On the moon, 11 pounds. Let's take a closer look. The moon's surface is covered with countless circular imprints. These circles look somewhat like a bowl, with an outer raised rim and an inner circular depression. These features are called craters. When rocks called meteors bombard the moon and planets, the collisions create craters. The formation of large craters is a very spectacular and violent event. Here is a simulation of how a crater is formed. This is a typical crater. Notice the flat floor that curves up into a rim just like a bowl. This very large crater has spokes around the rim called rays. Rays are formed by the rocks and dust scattered by the energy of the meteor smashing into the moon. The moon always keeps the same side toward Earth. We can see patterns of light and dark on the moon. The light-colored areas are rough and mountainous. The dark areas are relatively smooth. Early astronomers thought these dark areas were seas. They are actually very large craters created by huge meteors and filled in by dark-colored lava. The early astronomers were partly right. They are seas, seas of frozen lava.
Computer, can we see what the moon looks like from down on the surface?
Yes, we can. We'll land on the surface and you can look around. As you can see, the surface is made up of dusty soil. The dust does not blow around because the moon has no atmosphere. The moon's surface is littered by rocks of varying sizes. The moon's soil, called regolith, is the result of the moon being pulverized by space debris over eons of time. The large impacts have sprayed rocks, boulders, and dust all over the moon.
Bernie, isn't the moon beautiful? I would like to stay longer, but I'm too excited about seeing the other planets. Where do we go next?
Our next course will take us closer to the sun for a look at the planet Mercury.
Oh, good. And while we're on our way, I can review what I've learned about Earth's moon. The moon is covered by craters. The moon's soil is called regolith. The moon has no atmosphere. We can only see one side of the moon from Earth.
Heading, Mercury. Distance from Sun, 57 million kilometers. Revolution around Sun, 88 Earth days. Diameter, 4,878 kilometers. Surface temperature, 370 degrees Celsius on the day side, minus 184 degrees Celsius on the night side. Here is how Mercury's gravity compares to Earth's gravity. Nina's weight on Earth, 65 pounds. On Mercury, 18 pounds. While we're on our way to Mercury, let's talk about days and years. A year is the time it takes a planet to make one complete trip around the sun. On Earth, this takes 365 days, but Mercury does it in only 88 Earth days. Mercury's year is 88 Earth days long. A day is the time it takes a planet to rotate one time on its axis relative to the sun. Earth rotates once every 24 hours. Mercury turns very slowly. One Mercury day is equal to 176 Earth days. This means that Mercury's day is twice as long as Mercury's year. Nina, if you were 8 Mercury years old, you would only be 4 Mercury days old. Just think, on Mercury, you would have 2 birthday parties every day. That seems too good to be true, but remember, a Mercury day is equal to 176 Earth days. We are close enough to Mercury to see it on the view screen. There it is, moving in front of the sun. Mercury is the closest planet to the sun. Because we are so much closer, the sun appears to be much larger. Mercury is the second smallest planet in our solar system. The smallest is Pluto. Mercury's surface temperature ranges from a sizzling 370 degrees Celsius to a bone-chilling minus 184 degrees Celsius. This is the greatest temperature range of any planet. Now we can see the surface of Mercury. There are craters everywhere. Like the Moon, Mercury was heavily bombarded by meteors early in its history. One of the meteors that struck Mercury was much larger than the others, perhaps 150 kilometers wide. There's the result. That crater is called Caloris. It covers an area over twice the size of France. The collision sprayed rock hundreds of kilometers out to form the rim of the crater. The floor of the Caloris crater was cracked by the force of the collision. Later, Mercury's crust began to wrinkle and contract, and the cracks developed into sheer cliffs which are 3 kilometers high. There are areas on Mercury with fewer craters. These are known as the smooth plains. They were most likely formed by sheets of lava, which filled in the low-lying areas. The smooth plains are similar to the dark areas of the Moon. Everything that has happened to the surface of Mercury for billions of years is left for us to see. Mercury has almost no atmosphere to blow dust around. Mercury appears to have no active volcanoes. It has been a dead planet for billions of years.
I hope Bernie and I don't ever have to live down there. Are the other inner planets like Mercury?
No, Nina. They are all very different. Our next destination is Venus. It is as different from Mercury as night from day.
Good. You drive and I'll review what I have learned about Mercury. Mercury is the nearest planet to the Sun. Mercury has almost no atmosphere. Mercury is the second smallest planet in our solar system. Mercury has very long days and very short years.
Heading Venus. Distance from Sun, 108,200,000 kilometers. Revolution around Sun, 225 Earth days. Diameter, 12,102 kilometers. Surface temperature, 480 degrees Celsius. Venus's gravitational pull is slightly less than Earth's gravitational pull. Here is how much you will weigh on Venus, Nina. Nina's weight, on Earth, 65 pounds. On Venus, 57 pounds. On Earth, we see Venus as a bright, beautiful morning and evening star. It's always wrapped in lovely clouds. In fact, it was named after the Roman goddess of love and beauty. Venus's year is 225 Earth days long. On Venus, the sun rises every 117 Earth days. If you could see the sun through the always overcast orange sky of Venus, you would see the sunrise in the west and set in the east. This is because Venus rotates in a different direction than Earth and all the other planets in the solar system. Venus is the second largest inner planet, only slightly smaller than Earth, and it's the second planet from the Sun.
Is there anything alive down there? Bernie wants to know if there might be space monsters or something.
I certainly don't think so, Nina. I mean, Bernie. It was hoped that beneath the lovely cloudy veil, we would find a planet teeming with life. However, sometimes beauty is only skin deep, or in the case of Venus, cloud deep. The more we learn about Venus, the more unpleasant the planet seems. Venus has a layered, circulating cloud structure in the uppermost atmosphere. The clouds swirl around the planet at hundreds of kilometers per hour. These beautiful clouds are composed mostly of corrosive sulfuric acid with small amounts of water vapor. Venus gets worse at the surface. Underneath the clouds, Venus's atmosphere is about 98% carbon dioxide. The atmosphere is very dense. An atmospheric phenomenon known as the greenhouse effect raises Venus's temperature to 480 degrees Celsius. That's 900 degrees Fahrenheit. Sunlight penetrates Venus's thick clouds and is converted to heat. The carbon dioxide and water vapor in the clouds do not allow the heat to escape back into space. This creates a planetary heat trap that makes the surface so very hot.
I hope we don't get that much carbon dioxide in our air.
Well, Nina, I don't like to be a downer, but here is what can happen to the Earth if there is too much carbon dioxide in the atmosphere. We only have a few pictures of the surface of Venus because of the terrible heat and clouds of acid.
If it's so terrible, how did anyone get a picture?
A Soviet spacecraft landed on Venus and lasted just long enough to radio back several pictures like this one. America's Magellan spacecraft mapped the surface with radar, and these images were made by a computer like me. Here are some very large craters. This one is 100 kilometers across. These giant volcanic domes are 25 kilometers across. This area south of the Venusian equator shows how part of the surface of Venus has been twisted into a huge mountain range. This image is from an area north of the Venusian equator and shows a relatively flat surface cut with ridges in one direction and by unusual markings in the other. These features are not seen on any other planet. Venus is a strange and unusual world.
It sure is, Mr. Computer. But Bernie says he's getting hot. Let's go to Mars before he sweats on your circuits.
Okay, we're going. I'm laying in a course for Mars. We're going to need our heater on Mars. You had better do your review.
Venus is the second planet from the Sun. Venus is slightly smaller than Earth. Venus rotates in the opposite direction from the other inner planets. The greenhouse effect makes Venus very hot. Venus's atmosphere has clouds of sulfuric acid.
Heading, Mars. Distance from Sun, 227,900,000 kilometers. Revolution around Sun, 687 Earth days. Diameter, 6,786 kilometers. Surface temperature, variable. Averages minus 50 degrees Celsius. Let's see how much you will weigh on Mars. There is much less gravity on Mars than on Earth or Venus. Nina's weight on Earth, 65 pounds. On Mars, 25 pounds. Did you know that the Martian day is about the same length as a day on Earth? However, a year on Mars is about twice as long as a year on Earth. Mars has long summers and winters. There it is, Mars, the fourth planet from the Sun.
Gosh, Mars is sure pretty from up here.
Yes, it is also a very interesting place. For instance, Mars has two tiny moons, Phobos and Deimos. Let's go and see them. There's Phobos, which is the nearest moon to Mars. Phobos is only 27 kilometers long. This moon orbits Mars very quickly, twice each Martian day. This is Deimos. It is about 14 kilometers long and very irregular in shape. In fact, it looks like a big potato. The Mars we see from Earth appears to be a reddish star. It has long been called the red planet. There's the surface of Mars. It is red. This red color comes from a thin layer of iron oxide, which is another name for rust. It coats many of the rocks and dust particles on the planet. The red planet could also be called the rusty planet. Mars has violent dust storms. The wind can blow hundreds of miles per hour. Sometimes these storms rage over the entire planet, enveloping it in dust, which reaches over 17 kilometers high. The sand, dust, and Martian winds have formed these sand dunes. In the past, many people on Earth thought that there were great cities on Mars. Now we know that the conditions on Mars are not favorable for life. The Martian atmosphere is very thin and made up mostly of carbon dioxide. Oxygen-breathing organisms could not survive, but primitive organisms which are not dependent on oxygen could exist. The Voyager spacecraft scooped up some Martian dirt right outside our window and tested it. No evidence of life was found. However, the Martian surface does show evidence that there were once large amounts of liquid water. We see canyons eroded by water and old river channels. This means that long ago, Mars was not nearly so cold, and some sort of life may have developed.
What happened to all the water?
Some of it is in the Martian clouds. Some of it was lost into space, and some may be frozen below the surface. The polar ice caps have some water ice, but they are mostly carbon dioxide ice. The ice caps become larger and smaller with the Martian seasons, and can be seen from Earth with a telescope. It is very cold on Mars. Even on the Martian equator, the average temperature on Mars is minus 50 degrees Celsius. That's 60 degrees below zero Fahrenheit. The Martian surface has many contrasts. The southern hemisphere is made up of densely cratered highlands with some plains which are less heavily cratered. The northern hemisphere is a large plain with relatively few craters. Near the Martian equator is a region with some of the most spectacular landforms in the solar system. Crowning this highland area are several monster volcanoes, larger than any others in the solar system.
Can we fly down and see one of them?
Yes, we can. We can fly right around one. The greatest mountain in the solar system is Olympus Mons. It is 600 kilometers across and rises 24 kilometers above the surrounding region. That's 15 miles high. Now, I'll pilot us through Mars' Great Canyon known as Valles Marineris. It is the largest canyon in the solar system. It is 4,000 kilometers long, up to 7 kilometers deep, and over 600 kilometers wide.
Hang on, Bernie! Wow, that was some ride.
Mars is the last of the inner planets. I'll set a course for Earth while you review your facts about Mars.
Mars is the fourth planet from the Sun. Mars is known as the red planet. Mars may have life, or perhaps had life long ago. Mars has the largest mountains and canyons in the solar system. Mars once had rivers. That's how it all really happened. It was so much fun. I am going to order a new software program. Then I will be able to tell you all about the giant outer planets and Pluto. Goodbye for now. I'll see you for the next adventure.
This has been a presentation of Allied Video Corporation. We produce a variety of video products for the classroom. For a complete list of these and other educational tapes, please call toll-free 1-800-926-5892.